So I'm going to call this on page 15, all right? State whether or not, I should say, whether or not AB is parallel to CD. And I want you to justify. That's big in this unit, justify. Explain, basically. So let's start here. We have a line there, another line there. I'm going to keep them basic at first. Another there. And I will say that this is 110 and this is 110. So this is question A. Okay? B. So obviously they look parallel, but we don't know for sure if they are. We have to do some sort of test. I'm gonna say here. And then C. Oh, and A, B, C, D. Where is that, Mr. Dixon? What about that? Let's just do, right, we're gonna go A, B, C, D like that. Same with this one up here. A, B, C, D. Whoa. Let me just think here a little bit. I'm gonna call this eight. And then one more. And then AB, the lines in question here. Let me just focus here, and I will maybe make sure the numbers are legible there. So just if you look up here real quick, this is 130. This is 58, right? You got that? 130, 58. This is 60. This is 119. 79, 79. And then this is 110, 110. I think that one it's pretty legible there. So for each one of them, you're going to say whether or not AB is parallel to CD. So, and then why is it that you came up with that conclusion? Remember the four pairs, right? You can say because alternate interior are congruent, and corresponding angles are congruent, whichever one you happen to use at this point, right? And remember, vertically opposite angles are always there to help you find any missing angles, right? You might want to come up with an angle to find that pair that we have a name for, okay? Tell me on the diagram, maybe use a different colors, like on the diagram, as you're starting to fill stuff in there, tell me why you got that, right? Tell yourself how you came up with the extra angles that weren't given from the very beginning, right? So go ahead, try your best, because you're going to see a lot of this, okay? So, and if you don't know the answer, just say, don't worry, there's going to be more coming down the pipe, okay? So, whenever you're considering the parallel lines, or right now we don't know for sure, you want to focus on the transversal, right? The transversal is sort of the one that connects the two worlds, if you want to call it that way. And it's along that transversal where you find those four pairs that we're talking about. And in this case, you should recognize, hey, this one and this one here, they are actually alternate exterior, right? So I'm going to say, I see that they're congruent, and that's exactly what needs to happen for lines to be parallel. So then you just conclude, like there's not much else to do here. So you'd say that AB is parallel to CD, right? Because alternate exterior angles are congruent, right? So that's all you need to do there. Okay. And then on this one over here, we focus on that transversal again. So just remember, soon you're going to have multiple transversals, but you just want to focus on one at a time. Don't focus on all of them, because you're going to get confused, right? So just highlight the one you're on. You travel on this one. Along that one is where we focus our attention. And I look at both numbers, and they're the same. So most likely parallel, right? But what name do we have for these two here? They correspond, right, to each other. They're called corresponding. They don't have to be the same. They're corresponding whether they are the same or not, whether they are congruent or not. In this case, they are congruent as well, which is the condition we need to meet, right? So we would say AB is parallel to CD because corresponding angles are congruent, right? By the way, you would have to go back to last week's lesson. We also know, if this is true, we also know that alternate interior angles would be congruent. We know that alternate exterior angles would be congruent, and that the CIAs would add up to consecutive interior angles, in case Mr. Proskin wasn't here. So consecutive interior angles add up to 180. If we were to dig deeper, we would actually find that out, okay? So remember that, because, right, if this is 79, then this turns out to be 101, because they're supplementary along here. And these are consecutive interior angles. They add up to 180. We could call this 79, right? Because vertically opposite angles are congruent. And all of a sudden, hey, alternate interior angles are also congruent. So, but you only need to show that one of those is true, and then you're done. Like, you don't need to continue that further. All right, next, here. I focus on the transversal, right? And I'm not going to highlight those angles because I don't have a name for them. Exterior, they're both exterior, but they're not alternate, right? So we got to do a little bit of work here. So maybe I already used alternate exterior, right? But that's okay. That's okay. So maybe what we'll do is figure out that this is 122 here, right? This one right here, 122. And I'll just say that, right? Straight angles equal to 180. Later on, I'll give you space to do this, but for right now, that's okay. And then I realize, okay, this angle right here and this angle right here are called corresponding. And you might think like, what about that third line? Guys, I could add 1,000 lines in between. If we're considering AB and CD, forget about what's in between. Just follow that transversal until you get to the other world, right? And then here we are, corresponding angles. They're not the same, right? So we would say that AB is not parallel to CD because corresponding angles are not congruent. So that would be the explanation there. Are there different ways? Absolutely. I don't know if some of you you could have found that this is 58 here, and you could have found out that this is 50. So 58 and 50, these would be alternate interior. They're not congruent. Everything goes down the drain. So it doesn't matter how you approach it. It's flexible that way. Okay? It's flexible. Okay, one more. I wanted the CIAs to show up here because we don't use it very often. So what I will do here is I will say that this is 119, and I'll say vertically opposite, right? I'm just going to make an arrow to say vertically opposite. And I don't necessarily want you to erase and redo if you found a way of doing this, okay? That's where my keys are going to be a bit frustrating because you're going to look at the keys and it's like, why did you do it that way? I did it different way. Just go with it, right? As long as your answers add up, it's usually right. Okay. So here I say that I'm just going to show real quick. 60 plus 119 is 179, right? I'm just going to quickly add that up, and then I would say that AB is not parallel to CD because consecutive interior angles do not add up to 180, are not supplementary. Do I need to justify and then state whether or not they're parallel, or does it doesn't matter which order you do them in? You can first say that this isn't true, therefore AB is not parallel to CD. It's up to you. Okay. So I thought I would just quickly, there's not a whole lot of this online, to be honest, but I made this using GeoGebra, and right now let's just focus on this transversal. If I asked you whether this line is parallel to that line, right, you can tell, right, corresponding angles, no matter where you look at it, 75 and 75 is corresponding, right? All the corresponding angles are the same. Alternate interior angles are the same. Alternate exterior angles are the same. CIAs on this side, 180 here, 180 there. Let's focus, like I can change this, right? It doesn't matter what I do with that transversal, they're always still staying the same, right? Unfortunately, you cannot do this on your worksheets, right? But it would be cool. But it doesn't matter if you take another transversal on this side, right? Corresponding angles are still the same. Alternate exteriors are still the same. CIAs, right? They add up to 180 on either side. It's all the same. Okay. And so keep that in mind. And how you approach it is going to be up to you, how you approach these. But technically, guys, If lines are parallel and I just give you one angle, listen carefully. If I could just give you one angle, you could technically fill in all of the angles along that transversal. If lines are parallel, that is. If they're not parallel, you're kind of stuck, right? And you can't do that. More of that later. Okay, we're gonna go back in time a little bit. We're gonna go to page 12 before I up it. Sorry, 13. I meant 13. I have a plan. Mondays after a long weekend, I'm a little rusty, so you gotta kind of bear with me a little bit. I don't know if you follow the forecast, but it snows forecasted on Wednesday. So unfortunately, we're gonna start seeing more of that. That's part of being Manitoba. So page 13, highlight this part, right? Determining, like we're gonna introduce some algebra here too. And how do you deal with them is really not that, it's not very different from what we've been doing, except for now you need to actually solve for the unknown, the variable x, right? So this is how you approach this type of question. You realize that this is an angle, but it's written in terms of x in this case. It could be written in terms of m, n, z, it doesn't matter. What you want to look at is, hey, what do we know about, in this case, what do we know about this angle and this one here? Oh, I'm missing the biggest point of all. What are they telling us? They're telling us that the two lines are parallel, right? So now we can make the assumptions that of those four pairs, we can make all of those assumptions that the first three are congruent and the CIAs are 180. What are these called? Alternate exteriors, right? So we know they're alternate exterior. And what do we know about alternate exterior angles? They will be congruent. They will be, because lines are parallel, right? We're not proving that, we just go with it. So therefore, you start like this. 21x plus 6 is going to be equal to the other angle, which in this case is 90 degrees, right? So you just put in 90 degrees. And now it's just algebra, right? So I used to show you how to bring things over. I will isolate x. That's my ultimate goal, isolating x. So opposite operations, right? So you go 21x is equal to 90 minus 6. You want to do that. And that gives you 21x is equal to 84. Most of the time, these end up as being nice round numbers. Most of the time. And what happens next? Once you add or subtract, now the opposite of that is dividing, right? So we divide both sides by 21. X is equal to 4, right? And it's going to be in degrees. So now you found out what x is. You should be able to now go back to this angle, plug in x, and it should be 90, correct? Like if we plug that in, so check. That's if they ask you to actually state the angle, right? So that would be 21 times 4 plus 6. 21 times 4 is 84, plus 6 is 90, right? 90 degrees. So it checks out. Let's do 24. Question 24 on page 13. Because there you have both angles. Both angles are written in terms of x there. And again, they're guaranteeing us that lines are parallel. And this angle corresponds to this angle, right? So I have a name for that. So I'm just going to say, hey, corresponding angles are congruent. They're the same. Okay. The only one that isn't the same would be the CIAs, okay? They add up to 180, so that's going to be a little different. So let's go 23x minus 5 is equal to 21x plus 5. Whoa, there's too many x's, right? So what I do is I bring all the variables over to one side and all the constants or all the numbers over to the other side. So I'll say 23x, and the 21 is on the right hand side. So when it comes over, it will go subtracting. And on the other side, you already have this 5 here. So this other 5 will come over. So when you cross the equal sign, you change sign, right? So it'll be plus 5. And so 23x minus 21x, that's 2x. 5 plus 5 is 10. We now divide by 2. And x is equal to 5 degrees. It's always in degrees. Now, if they ask you, like, well, what are those angles? State them. We can check, right? So I'm going to make a line here, and I'm going to say 23 times 5, right? I'm following this one, minus 5 is equal to 3 times 5 is 15. So that's 115 minus 5. That would be equal to 110 degrees. And then this one we know is going to be 110 as well, correct? Because 110, 110. But let's just check if we're supposed to figure that out. Once we find x, you just substitute that in. Okay. And that'll be 5. So 105 plus 5, that is 110, which we knew. So if they ever ask you to state the value of those angles, then you need to take that one extra step. But if it's just asking to solve for x, then you stop there. Okay. I want you to try 21 and 23 right now. Okay, questions 21 and 23 right now on your own. And then I'll show you one more on the other side, and we'll move on to different waters. How's that? All right. Hopefully you got this. So alternate interior. We know something about alternate interior. They're congruent, right? I'll say alternate interior angles are congruent. So 8x is equal to 60 plus 4. 8x is equal to 64. X is equal to, what's the answer? All right, just making sure you're awake. 8 degrees, there we go. That's all you needed to do there. And then one question where you had both angles in terms of a variable. So minus 1 plus 14x is equal to 12x plus 17. I know that because they're alternate exterior. So I'm going to go 14x minus 12x, right? That comes over. And I'm going to go equals. 17. The negative 1 comes over adding. So that's 2x is equal to 18. Divide both by 2. X is equal to 9. Voila. Right? That's as much French as you'll get from me in this class. Right? So hopefully you got that. So the other two, I would say, try them for homework. See if you are quite comfortable with them, because usually ACs have one question here and there like this, just a quick. Do you remember how to do that? Okay. So I'll write that down later on so that we're prepared for it. And here are the infamous CIAs. It says solve for x. This is on page 14. Solve for x, then determine the value of both angles. So not just solving for x, but also figuring out what those angles are supposed to add up to. So I'm going to do this one. Again, we're told that these two lines are parallel. Now I can make assumptions. I can say that consecutive interior angles, they're not congruent, right? They look congruent, but they add up to 180. Okay. That when they're like that, I don't say that they're equal. Right? I say that they are supplementary. They add up to 180 degrees. So let me zoom into that one. There you go. So you go like this, x plus 96. It's almost like you're taking that angle and you're going to add the other angle to it. Okay? And that is equal to 180. So that's how this one is different. Okay? This type is different. You don't just say they're equal to each other. Okay? So we don't need the brackets in this case because there are no negatives. Like it's just adding there. So we'll go x plus 96 plus x plus 96 is equal to 180. We combine our x's, right? So that'd be 2x. And on the other side, I'll go 180. How about this? I'm going to go minus 96 minus 96. Right? Both of these come over to the other side. 2x is equal to 96 and 96, that's 192, right? Negative 192. So that ends up being a negative value. So 180 minus 192, that ends up being negative 12, like that. So don't forget about negatives. And so divide both sides by 2. I usually use a red pen, but that's okay. So that'd be negative 6 degrees. So yes, believe it or not, it's negative, right? Like it will make sense now that we place the x values into our angles, and we just need to do it once, right? Negative 6, substitute that in, plus 96, that equals to 90 degrees. Okay. They're both 90 in this case. So 90 and 90 adds up to 180. That's why they were exactly the same when we. So it's a bit deceiving because you're like, oh, they're the same. Don't fall for it. They're not the same. They add up to 180 degrees. So before I move on, I want you to try the one next door. This one right here. Before I move on, and then we'll try the next one there. So here we go. We're still writing this down. I'm going to leave that up. You try that one. And I'll try to give you the answer to that. So remember, there are CIAs. So these two angles add up to 180. I just go ahead and add up my my x's, and then 5 minus 1, right? That's 4. You end up with 180 on the other side. You bring the 4 over, subtracting. You get 44x is 177. Divide both sides by 44, you get 4 degrees. You substitute it into the first expression here, which is 85. You could technically skip this step and just go 180 minus 85 to get the 95 if you wanted to, but I guess this just gives you, this reassures you that you did it right. Okay. Let's move on to, and I think I'm going to make a separate video for